The global population, well, it continues its climb, and the question of how we'll sustainably feed everyone, it just becomes ever more critical. It's a monumental challenge, really. But what's genuinely exciting is seeing how these cutting edge technologies are offering some pretty powerful solutions.
Absolutely. And in this deep dive, we're focusing on how artificial intelligence, AI, and the Internet of Things, IoT, are fundamentally reshaping agriculture. And, with sustainability as a core driver, we'll be drawing quite a bit from the insights of FarmNet. They're real innovators in this space.
Right. And we've also dug into some articles exploring the broader economic impact of ag tech, including some fascinating case studies. And there's this really detailed piece on how remote sensing and AI are specifically revolutionizing the fight against agricultural pests. Super interesting stuff.
Hmm.
So, our goal today really is to understand how AI and IoT are making farming not just different, but, smarter, more environmentally sound, and ultimately more productive, tackling everything from resource management right down to those persistent pests, all while keeping an eye on that bigger economic picture.
Exactly.
Okay, so let's unpack this. How exactly are these digital agriculture solutions changing the landscape of farming?
Well, what's really striking is just the sheer breadth of this transformation. Digital agriculture, it's impacting nearly every facet of farming. I mean, from the initial planning stages right through to the complexities of supply chain management. It's a truly end-to-end evolution.
So it's much more than just, updated tractors in the fields.
Oh, precisely. Yeah. While advanced machinery is definitely a component, the real power, it lies in the data and the intelligence we can actually derive from it. AI algorithms are processing just vast amounts of data information streaming in from satellites, from weather patterns, even sensors, like embedded right there in the soil. It's providing farmers with levels of insight that were, frankly, unimaginable before.
That paints a very clear picture. It's
Yeah.
like having this incredibly knowledgeable advisor sort of overseeing every single inch of the farm. And where does the Internet of Things, the IoT, fit into this whole data-driven approach?
So the IoT is essentially building this network of interconnected smart devices right across the farm. These devices, often sensors, are continuously gathering real-time data on crucial factors,
Yeah.
things like soil moisture levels, nutrient composition, and the overall health of the crops themselves.
Wow. So instead of relying on, manual checks across potentially huge fields, farmers are getting this constant flow of up-to-the-minute information.
Exactly. And these IoT devices, they feed all that collected data into cloud-based platforms. Think of it like securely storing and analyzing your farm's vital signs in an online space you can access from anywhere. This accessibility, it lets farmers make much more informed, much more timely decisions about critical tasks
Yeah.
like irrigation, fertilization.
Right. And I came across the term remote sensing. Is that basically like having a constant aerial view of the farmland, maybe from, say, drones?
That's a good analogy, yeah.
Hmm.
Remote sensing uses technologies like satellite imagery and drones to provide a much wider perspective on the fields. This sort of bird's eye view can be invaluable for identifying large-scale issues, maybe areas of crop stress far earlier than you might catch them just by walking the fields.
Okay. So we've got these sophisticated digital tools. How do they then translate into practical applications like precision agriculture?
Right, so the core principle of precision agriculture is really to move away from that uniform, one-size-fits-all approach to managing an entire field. Instead, it's about recognizing and, crucially, responding to the specific localized needs within that field.
So no more treating every single part of the farm exactly the same way.
Correct. Precision agriculture leverages all that data we've been talking about to implement targeted interventions. And with remarkable accuracy, take variable rate technology, VRT. This lets farmers apply inputs, fertilizer, pesticides, water at varying rates across a field, precisely matching the requirements of each specific zone.
That sounds incredibly efficient.
It is. And what's really significant about VRT isn't just saving on input costs, though that's important. By precisely targeting nutrient delivery, we're seeing evidence of reduced nitrogen runoff into waterways, which, has this cascading positive effect on aquatic ecosystems.
Ah, okay.
That's a level of environmental benefit we just couldn't achieve with the older sort of blanket application methods.
That makes sense, leading to less waste and hopefully, yeah, a much better environmental outcome.
Absolutely. And GPS-guided machinery plays a really crucial role here as well. These tractors, harvesters, they can operate with centimeter-level accuracy, minimizing overlap, dramatically increasing operational efficiency. Plus, continuous crop monitoring lets farmers detect problems. Maybe it's a pest outbreak, maybe a nutrient deficiency much earlier, and address it proactively before it really escalates. Pharmanaut's satellite-based crop health monitoring is a perfect example of this tech in action.
Okay, so we've covered the what and the how a bit. Now let's focus specifically on AI. What is its, revolutionary role in this agricultural transformation?
Well, AI really serves as the intelligent engine driving so many of these technologies. It takes the vast amounts of raw data collected and transforms it into, well, actionable insights. We're seeing AI being applied to a really wide range of tasks, from forecasting weather patterns and predicting potential disease outbreaks to even controlling autonomous farming equipment.
Autonomous equipment? Like we're talking tractors that can operate without a driver.
Exactly, yeah. And think about robotic harvesters, capable of identifying and selectively picking ripe produce. But AI's impact isn't just limited to the big machinery. Pharmanaut's Jeevan AI advisory system, for instance, offers personalized advice directly to farmers. It empowers them to make really well-informed decisions across their entire operation.
Wow, it's like having a highly experienced agricultural consultant just available 24/7. Now let's delve a bit deeper into the Internet of Things. How does it actually facilitate this interconnected farm ecosystem you mentioned?
So the IoT acts as the sort of connective tissue, seamlessly linking all the different elements of a farm through a constant flow data. Those smart sensors we talked about, they're continuously communicating with each other and with central data management systems.
So a sensor measuring soil moisture could directly influence the operation of the irrigation system.
In essence, yes. The sensors collect data on a whole range of environmental parameters: soil moisture, temperature, humidity, you name it. This data is then transmitted, often through a central gateway, up to the cloud for analysis. The system can then potentially trigger automated responses, like activating the irrigation system when soil moisture dips below a certain threshold.
Mm-hmm.
And the applications, they go beyond just crops. IoT is also being used to monitor the health and well-being of livestock, and even track the conditions of agricultural products as they move through the supply chain.
This all points towards a really significant potential for making farming more sustainable. How precisely do AI and IoT contribute to that specific goal?
Right. This is where the real synergy becomes apparent. By enabling precision resource management, these technologies empower farmers to apply only the necessary inputs, precisely when and where they're needed. This leads to a dramatic reduction in the overuse of water, fertilizers, pesticides.
Which, yeah, clearly translates to pretty substantial environmental advantages, less waste.
Absolutely. We see less runoff of chemicals into our waterways, for one. A reduction in greenhouse gas emissions associated with fertilizer production and use, and even the potential for improved soil health, which, can act as a significant carbon sink.
Okay.
Smart farming practices can also contribute to biodiversity conservation by enabling more targeted interventions instead of those broad-scale treatments. And think about water conservation. Smart irrigation systems, guided by real-time data, can optimize water usage. AI can even aid in selecting drought-resistant crop varieties through assisted breeding programs.
Wow.
Furthermore, sophisticated data analytics that can improve the accuracy of yield predictions, give farmers better insights into market trends, help mitigate risks from weather events, and even streamline the entire supply chain to minimize food waste.
So it really does seem like a truly beneficial cycle, better for the environment and potentially more profitable for the farmer, too. Now, let's shift our focus a bit to the economic implications. How does all this agricultural technology connect with broader economic growth?
Yeah, the article Economic Growth and Smart Farming really hammers this vital link home. Increasing agricultural productivity is absolutely crucial for feeding the expanding global population. We need to remember the UN projection nearly 10 billion people by 2050. The demand for food is going to be just enormous.
Right.
And it's not just about more food. Think about the creation of completely new, high-skilled jobs, data science, robotics maintenance, ag tech development. These are entirely new economic sectors emerging directly from this agricultural revolution. That's a fundamental shift, especially for the rural economy.
And I suppose with land available for farming becoming increasingly limited in many parts of the world, we just have to become much more efficient with the land we do have.
Exactly. With diminishing agricultural land and that ongoing migration from rural to urban areas, boosting productivity per unit area through technology integration, it becomes indispensable.
Yeah.
It's a necessity. The article even touches upon various economic growth theories, from the early physiocrats who saw agriculture as the primary source of wealth, to classical economists emphasizing capital and technology, and then the more contemporary endogenous growth theories that really see tech innovation as a key internal driver of sustained economic growth.
So this idea that agriculture plays a really critical role in economic well-being, It's not exactly a new concept then.
Not at all, no. Throughout history, agricultural growth has been a foundational element in economic development, both for developed and developing nations. Some studies have even shown a direct causal link increases in agricultural production, leading to broader economic expansion.
Interesting.
The key takeaway is that continuous advancements in agricultural technology aren't just, nice to have. They're a fundamental prerequisite for long-term economic growth.
The article also mentioned this concept of moving towards agriculture 4.0. What does that actually signify?
Yeah, think of it as the latest stage in how agriculture evolves. We've seen previous big shifts, right? The mechanization from the Industrial Revolution, the massive yield increases of the Green Revolution, Agriculture 4.0, or smart agriculture. It's essentially powered by the technologies of what we call Industry 4.0, things like microprocessors, sensors, cloud computing, autonomous systems.
So it's taking the whole digital revolution and fully applying it to the actual processes of farming.
Precisely. That's a good way to put it. The overarching goal is to leverage these technologies to achieve more efficient, higher quality, and more profitable farming practices, largely through the capabilities of the Internet of Things.
And how is this smart agriculture specifically defined in the sources?
Broadly, it involves using modern tech and techniques to optimize soil and crop management and also the efficiency of resource use. It's really about harnessing the power of the cloud, big data analytics, and IoT to monitor, automate, and analyze, well, pretty much every aspect of farm operations. You might also hear the term climate-smart agriculture, which has a specific focus on promoting sustainable development and food security, especially in the context of a changing climate.
Right. And the article laid out 6 key components of smart farming, didn't it? What were those again?
Yes, that's right. Okay, so first you have sensing technologies. These are all the various sensors collecting data on a whole range of farm parameters.
Yeah.
Then communication systems, crucial for transmitting that data effectively, and for farmers to get timely info. Software applications are what let us interact with and analyze the data. Telematics combines telecommunications and informatics, basically, wirelessly transmitting data between farm equipment and central systems. Positioning technologies, like GPS, vital for that precise application in the field. And finally, data analytics solutions, the tools and processes used to interpret these huge amounts of data and pull out meaningful insights.
Got it. So it's the interaction, the synergy between all these components that really creates a smart farm. And what are some of the major benefits we can expect to see from all this?
The potential benefits are really substantial. We're looking at improvements in soil fertility, producing healthier food, conserving our natural resources, early detection of harmful contaminants, even the possibility of generating green energy right there on the farm, and definitely increased time efficiency through remote operations. The primary goals are really to cut the costs associated with chemical inputs, minimize environmental pollution, provide higher quality agricultural products, improve the flow of information for better decision-making, and just establish greater organization and traceability throughout the whole agricultural sector.
And the article gave some really compelling examples of smart agriculture actually being implemented around the world, right?
It did, yeah, like that automated irrigation system in Spain by Telefonica. They're using GPRS tech to remotely manage irrigation across huge farmlands, and the result, significant savings in both water and energy.
Wow.
Then there's the example of that lettuce factory in Japan, using controlled environment agriculture with incredibly high rates of water reuse and extensive automation. And closer to the article's focus, Turkey has launched its National Technology Initiative and projects like the Vodafone Smart Village, using ICT to boost agricultural efficiency and productivity. The article even shows some trial data demonstrating how smart farming methods helped meet or even beat target fertility levels for various crops in different parts of Turkey.
Those real-world examples, they really illustrate the transformative potential here. Okay, now let's pivot slightly and turn our attention to that other article, exploring how remote sensing and AI are revolutionizing the management of agricultural pests.
Right. This article kicks off by emphasizing the numerous pressures facing modern agriculture. We've touched on the growing population, resource scarcity, climate change impacts, and of course the persistent challenge of pests and diseases. It really highlights the urgent need for innovative tech solutions. And this is where remote sensing and AML technologies really shine.
So it's about being proactive,
Yeah.
addressing potential problems before they cause major losses.
Exactly. Remote sensing, AI, machine learning, they offer powerful ways to gather precise, accurate data, which is fundamental for developing effective pest management strategies and predictive models. These technologies can help us understand soil better, manage water more efficiently, optimize nutrient application, and even create early warning systems for potential pest outbreaks.
We touched on remote sensing earlier. Could you maybe elaborate a bit more on the different types of platforms they use?
Sure. So remote sensing platforms are generally classified by their altitude. You've got ground-based platforms used for really detailed, localized investigations. Then there are airborne platforms. This includes aircraft like planes, helicopters, and, importantly, UAVs or drones. They offer higher resolution data and targeted coverage.
Okay.
And finally, spaceborne platforms. These are sensors mounted on satellites, providing global coverage, often repeatedly over time. India's recent Chandrayaan-3 mission, as mentioned in the article, is a current example of spaceborne remote sensing in action.
So from satellites way up there down to sensors right on the ground, we're collecting data from just a multitude of perspectives. How is all this data being used beyond just general monitoring? What are the applications?
Oh, the applications are incredibly diverse. Beyond just pest management, RS and AI are being used to quantify various crop characteristics, phenotypes, they call them. Also, forecasting weather patterns specifically relevant to pest activity, managing weed infestations, assisting in automated fruit harvesting, monitoring irrigation and fertilization effectiveness, and of course, tracking overall crop yield and health. The article even points to several companies actively developing specific AI-powered tools for these different jobs.
Okay. And specifically thinking about pests and diseases, how do remote sensing and AI actually work together?
Remote sensing captures detailed imagery of the plants. And then AI, particularly advanced deep learning models like convolutional neural networks, CNNs. Think of them as a type of AI that's really good at analyzing images. Can analyze these images to identify visual signs of plant stress and disease. It's essentially training a computer to recognize those subtle visual cues that signal, hey, there's a problem here.
So instead of a farmer having to physically inspect every single plant, the AI can automatically flag potential issues. That's incredible.
Precisely. And remote sensing can also estimate potential crop yield by analyzing what are called vegetation indices. Think of it like a plant's greenness score, as seen from space or a drone. Different levels of greenness, measured by how the plant reflects different wavelengths of light, tell us a lot about its health and vigor.
Right.
Thermal imaging can even be used to estimate, say, the number of fruits in an orchard. Then sophisticated AI models, like artificial neural networks, ANNs, can integrate all this data,
Yeah.
along with other factors like weather conditions, to provide much more accurate yield predictions than before.
That sounds incredibly valuable for planning, for resource allocation. But what about actually detecting the stress caused by pests and diseases?
Yeah, so RS and AML can detect really subtle changes in a plant's biomass, its pigment composition, its overall vigor, things that indicate stress. Historical weather data can even be used to predict the likelihood of certain disease outbreaks under specific conditions. Remote sensing can pick up on those very early physical and physiological changes in plants. Maybe slight discoloration, maybe stunted growth, often before it's obvious to the human eye. There are also more advanced technologies like fluorescence spectroscopy and even electronic nose systems. These can detect the very early signs of stress by analyzing volatile organic compounds, basically, the smells emitted by stressed plants.
Wow, it's almost like the plants are sending out this tiny early warning signal that we can now actually detect with this sophisticated tech.
Exactly. And AI algorithms, including things like support vector machines, SVMs, and long short-term memory networks, LSTMs. Again, AI models good at finding patterns in complex data. They're being used to predict the likelihood of plant diseases and pest infestations based on a whole variety of data inputs. There are even smartphone apps being developed now to help farmers identify pests and diseases directly in the field using AI image recognition.
That's very practical, and weeds, of course, are another huge challenge for farmers. How are RS and AI tackling that problem?
Well, remote sensing offers a much faster, much more cost-effective way to map weed infestations, especially across large areas, compared to walking the fields and surveying manually. Different types of weeds can even be categorized based on their visual texture in the images, which allows for more targeted herbicide application.
Okay.
And AI, often integrated with drone technology, can precisely pinpoint weed locations. It can even control robotic systems for applying herbicides with extreme precision. This approach significantly reduces the total amount of chemicals used, which is great for the environment, and it also helps manage the growing problem of herbicide resistance in weeds.
So it's about applying treatment with pinpoint accuracy, not just a broad spray. What about other kinds of stress, like drought or extreme heat? Abiotic stress?
Right. Remote sensing can detect changes in chlorophyll content and the way plants reflect light, which can indicate those abiotic stress factors like drought, high salinity in the soil, or heat stress. Specific vegetation indices like NDVI, which we mentioned, but also others like the Photochemical Reflectance Index, PRI, and the Moisture Stress Index, MSI, are used to assess water stress levels. And AI algorithms can then help predict and potentially even enhance crop yield under these challenging conditions, maybe by guiding irrigation strategies.
It really seems like AI is playing a role in pretty much every aspect of modern pest and stress management in agriculture.
It truly is. AI algorithms analyze a combination of factors, crop symptoms, environmental conditions, even the physical characteristics of pests and diseases to help with identification. Specific AI models, like convolutional recurrent neural networks and other types of CNNs, are being used to classify different kinds of leaf diseases just from images. And as we've discussed, UAVs, drones, equipped with various sensors, are becoming these really powerful tools for early pest detection and the precise, targeted application of pesticides only where needed. AI is even being used to analyze the reflectance patterns of crops captured by these drones to forecast potential pest damage and predict yields under those conditions, using models like CNN combined with LSTM for better accuracy over time.
This all sounds incredibly promising, almost futuristic in some ways, but are there any significant obstacles, challenges to the widespread adoption of these AI and RS technologies for pest management?
Oh, certainly. Yeah, the article highlights several key challenges. The quality and availability of good data can be a limiting factor sometimes. You need lots of good data to train these AI models effectively. Then there's the accessibility of these sophisticated technologies for all farmers, particularly those with smaller operations or in less developed regions. The cost can be prohibitive. The computational cost of running some of these advanced AI models can also be a significant barrier.
Yeah.
Plus, accurately identifying specific pest species, differentiating them from similar-looking beneficial insects, for example, can still be a complex task for AI. Wider adoption of drone-based monitoring, for sure. The emergence of smart traps and lures that use AI to identify and target specific pests. And hopefully, more accessible platforms for sharing valuable data among farmers, researchers, and advisors. Collaboration is key.
Okay. So, to sort of summarize our discussion then, it seems really clear that AI and IoT are indeed powerful forces transforming agriculture, making it more efficient, more sustainable across just a huge range of applications.
Exactly. From optimizing the use of our precious natural resources, water, fertilizer, to achieving much more effective management of pests and diseases. These technologies are directly addressing some of the most critical challenges we face in feeding a growing global population.
And that really feels like the core insight, doesn't it? The convergence of AI and IoT in agriculture, it provides this tangible, promising pathway towards feeding billions of people responsibly and effectively. Now, considering these rapid advancements we're seeing, applying all this tech to our farmlands, it does prompt a pretty significant question for you, the listener, to think about. As this agricultural revolution unfolds, what are the broader societal implications of increasingly automated and data-driven food production systems that we should be carefully considering? It's certainly a complex issue with many facets to explore further down the road. Thank you for joining us for this deep dive.